Markus. It was so interesting, and I think not many of us know this technique, so it was very nice to see that. I will share my screen for the questions. So first, why did you not consider the ultrasound speaker?
That was due to time constraints in this presentation, actually. We did, of course, use it. That's why it was on the picture. But ultrasound speaker, although it has a lot of upsides, like not annoying any inhabitants of the building because they just can't hear it, there is an even higher so the direction is even stronger with this high ultrasound transmitter. So when going to a window, for example, oftentimes you actually have to completely scan around the window to get every part of the frame. And then again, we are back to what we originally wanted to get rid of, the scanning mechanisms.
That makes sense. The next question, is there an option to convert the decibels into an airflow rate?
We did some investigation in the laboratory with this, or not only converting dB, but also the whole acoustic signal to see like if certain parts are getting sucked away, if you have different kinds of leakages. But up to this point, at least in our laboratory setup, we weren't able to find any reliable connection between the acoustic signal and the airflow rate.
Okay, thank you. Is the difference for the two speakers used in the field study only the frequency? It seems the directivity is different too, omnidirectional vs single direction.
Yes. In this case, that was also something you can consider, but we are also using a sound source that is omnidirectional and has a higher or can go into higher frequencies. And at least in this case, I don't think it made that much of a difference in maybe it did, but at this point we did not have a sound source, or when we did those measurements, we did not have a sound source that is omnidirectional and goes to such high frequencies. But it's something we're going to have a look at in other measurement campaigns, I guess.
To what point are resonant frequencies a factor? If it was a problem, how did you solve it?
We had a lot of resonance within our laboratory test bench, or at least maybe it's partly resonance, it's partly just going through the thin walls, because when we originally constructed the test bench, we had more in mind the airtightness than actually soundproofing it. And then after we realized during our first measurement campaigns there, a lot of sound just travels through the walls. We soundproofed the test bench. So I think we just got rid of this problem by soundproofing it. And in an actual building, you don't have this problem just because walls are so big. And since you're using white noise, I don't think that resonant frequency has ever influenced our measurements, at least that I know of.
Actually, I have a question myself. I see we have a little bit of time. I was wondering if with this acoustic method, what you measure, is it only dependent on the geometry of the leak? Or, for example, if you pressurize and you increase the airflow rate, will you also see an increase in what you measure?
So we don't use any airflow measurements while doing these measurements with the acoustic camera. Or
I'm not very familiar with the acoustic. I was wondering if it's just dependent on the geometry of the leak, or if there is more air flowing through it, will it also increase the the sound transfer, or?
Okay, but
Yeah.
the amount of air flowing through is also very much dependent on the geometry of the hole, right?
Yes, sure, but if you have if it's overpressured, will it change what you measure, or will it be a possibility to overpressurize the building to see more leakage with this method?
Okay.
Yeah.
Since we aren't doing any overpressurization while doing this measurement, it does not have any influence. And also, we tried doing some air tightness measurements with blower door while doing it. The problem is that the blower door is quite loud, and so it has more of an interference effect with our measurement than it does help it. So no, there's no difference between doing like 50 pascals or 150 pascals over pressurization inside.
Okay, thank you very much.